What's that?
Why did we skip the question?
That was a clicker question.
That's
Why,
what-
why did we skip the question?
You want to go back to the question?
Hold on.
That's actually right.
I wasn't paying attention. Okay. Well, that's,
It's all right.
why sure.
Way to go, you.
We'll give you 10 seconds because you all know the answer. I wouldn't want to cheat you out of the floor. That's really bad form. Okay. Let's see how we do. Yeah, right, nice blocks. Put them out there, you bury everything around them, but when they melt, they're the hole. They reverse the topography. And if it has the water table high enough, it's going to be filled with water, be a kettle lake. Okay. Okay, y'all remember Roche Montnets, right? They were erosional forms, weren't they? A nice kind of ground its way up the high, and then as it got to the high, the compression stopped, so the melting stopped. And instead of having this liquid sandpaper to grind the way up the slope, now everything started, the ice could kind of expand, it would freeze up now, and it would just pull blocks of that ridge off the backside, that quarrying effect. We saw this Roche Montnet with this nice, gentle slope, all polished up, and then it just drops off with this quarried, plucked face. Okay, but that gave us a direction, didn't it? It said this nice, polished face was the upstream side, the ugly, quarried face was the downstream side. We knew which way the ice was moving. Well, now, depositionally, we've got kind of the same thing, only it works just the other way. Here I've got what's called a drumlin. And you can see this drumlin. It's got a steep face here. It's got a nice smoothed out face here. But it's all depositional. This is all sediment. It's not bedrock. And now what we see is instead of the ugly quarried face being downstream, we see the blunt face of the depositional drumlin upstream. And then we see the sediment smeared out as the ice flows downstream, stretching it out. So in this case, it would be flowing from left to right. In this case, from right to left. And here you can see a couple of drumlins together. So again, you've got these great direction indicators. But now the symmetry, or the asymmetry, is reversed. It's blunt side up, streamlined side down. Now, I've got this glacier. It's pressure melting at the bottom. It's all water under there. And that water wants to escape out from under the glacier. And it finds a way, finds the front edge of the glacier. It erodes a channel up into the ice. And now that water's just squirting out from under the ice. And that channel under the ice is acting just like a river channel, kind of upside down. Now instead of a channel being cut into bedrock, the channel's cut up into the ice, and the river is flowing through this channel just like it would if it were cut through bedrock. And it's dropping sediments. The glacial walls of the tunnel are providing the banks of the stream. It's filling with sediment. But eventually, this ice is going to melt. And what's left is the sediment that was deposited in that tunnel system under the ice. And we can see these segments. Like here's a segment here. You see a big segment coming through here. And these are called eskers. So these kind of wiggly, sinuous, snaky-looking things on the topography kind of give you an idea where the drainage under the ice used to be. And these sediments were all laid down as river channel sediments, right? So you're going to see sorted, striated, layered sediments that look like they came from a fluvial system. So we've got glaciofluvial system type of deposits that make up these eskers. So Eskers are the result of glacial ice squeezing and reshaping sediments as it runs over them. Is that true?
It's false.
3 seconds coming up. 19, 30, okay. Okay. Who was sleeping? Who wasn't paying attention? I can't believe you guys wouldn't pay attention. Hang on every single word that I said. Okay, now. The ice isn't reshaping these things. The ice isn't running over them and squishing them around. This is just simply filling in the tunnels underneath. It won't count. Don't worry. No extra credit there. Still running. So no, this is just sediment filling in the channels that are allowing the basal meltwater to get out from under the ice. That's all it is. Okay. Where was the ice? Where did the ice sit in this picture? Well, when you look at the topography, if ice was there, that meant sediment wasn't getting deposited there, right? Just like the Kettle Lakes. So here in this picture, it should be pretty obvious that the place where there wasn't sediment deposited is over here. This is all a delta system that grew off of the glacial ice, and that glacial ice was sitting back over here. And this sediment was being carried off the ice and deposited out there as a big, huge outwash delta. Now, once the ice finally retreated as it melted, this cliff was unsupported, so it's collapsed a little bit now. Normally when the ice was there, it would have been much steeper, maybe even kind of that way. But without that ice supporting it, it's found its angle of repose. But this former ice margin here and this delta here is pretty typical of a lot of things that we see. You can see these farm buildings back here for scale. We have this beautifully displayed here in Kalamazoo with the Kalamazoo moraine system. How many of you have driven on Main Street and becomes, 43, and you go into South Haven? How many have taken that road? Yeah, a lot of you. And you know how you start leaving 131 and you're headed west, and the road just kind of, it's undulating a little bit up and down, but overall it feels like you're kind of going up. And then just as you kind of get through the last of all of the residential stuff and the shops and everything, all of a sudden the road just kind of goes, whoom, it's got a big steep hill, and then it starts going across some kind of swampy area. You just went over the edge of the glacial moraine. That's this edge right here. You're coming from Kalamazoo, you're driving along, boom, you're at the top of the hill, you come down the hill, and there's the kind of swampy area you drive through. So it's a gorgeous example. And that Kalamazoo moraine starts there, west of Kalamazoo, about 4 or 5 miles west of Kalamazoo, and extends almost past Galesburg. So you're talking miles of landform all through this one depositional event. Okay, let's talk about glaciers up at my place a little bit, because there's some really neat glacial things up there. And this is one of them. We'll talk about that in a minute. But what's really cool, we looked at this map before. Remember we looked at it to talk about the river system. Because up here, the river system was being controlled by the fracture pattern, and we can see how the fractures were all setting up this rectangular drainage pattern there. But you can draw this dashed line here, And the drainage pattern completely changes. You don't see any of that down here in the southeast, the southwest. You still see signs of the fracture pattern in these big, long, straight segments of coastline. So that fracture pattern's still there. The thing is, you don't see it very well because it's buried. Because from here, along this dashed line, up here to the northeast, this has all been scraped down to bedrock. That's where the glacier was advancing and scraping things clean. But by the time it got to here, it couldn't hold all that sediment anymore, and it started dropping it out. So everything down in this direction now is the depositional system. So we're right on the edge between the erosional part of the glacier and the depositional part of the glacier. It's that evident. Just within a couple of miles, you can see the transition. It's really spectacular. So you're seeing this happen. The ice is flowing, the sediment's still coming, and you see this deposition going on out at the toe of the glacier. And you can see all of these recessional moraines now forming that way. And here we are in Kalamazoo, and here we are up at my place location, and notice how we're kind of just north of the moraine system. If I go about another 2 or 3 miles southwest of my place, all of a sudden there's this huge, giant moraine, and it's been mined for sand and gravel for years now. It's the big gravel pit for the whole area. So you can kind of see that now. If I go right over into here by Midland, to the town of Midland, that's where we start finally picking up these moraine systems. Okay, here's the island. Remember when we looked at it with the fracture system? And we could show that that was on the island. Well, okay. Ice flow came across the island from north to south, so it's moving in this direction across this fracture pattern. Here's what we see happening. Okay, our Roche Montagnes, remember? So here's north, here's south, and this is what we're seeing happening on the island. One side is all a gentle slope, glacially abraded. The other side is all quarried and plucked. I'll show you a couple pictures of that. Here's kind of the crest of the island in this yellow dotted line right here. And that would be that part of the Roche Montagnes. Back here, you get kind of the rubble. You're seeing this part of the Roche Montagnes. And all of this leading up to that is polished slope moving toward the high point. Notice how the joint control is getting plucked out on the back side. In fact, it is just spectacular. Okay, here's the abraded side. We're coming up, ice is flowing north to south. Here's your view, and you can just see this gentle slope as it moves up to the high point of the island. And look at the striations, the abrasion on the granite there. And you can see that same thing in the middle of the island, nicely polished, nicely smoothed off. Here at the other end of the island, you kind of see the same thing. All the rocks are rounded and polished, moving up to a high point. You get back here, it starts to get quarried off. Here's the back side of the island, and now we're kind of over in this area. The high point of the island is up here, and look how these blocks have just been pulled off the back side, all controlled by the joint pattern in the bedrock. And some of these joints, they're spectacular. It looks like somebody came along with a cement saw and just cut this. This is about a 7-foot tall cliff. And it just follows right along this joint. This side got plucked out. This part of the block is still there. Remember U-shaped channels in glaciers? Here's a glacial trough that's been worn right through the middle of the island. It kind of comes right through the back side, right in here. And if this had continued to have flow through it, it would have eventually just cut the island in half. And you can see on the back side now, where this rubble is accumulated, here's the high point of the island. And look at all the, plucked blocks that are still kind of sitting around and the sand and gravel that's developed. If I look to the island right next door, it's just this little tiny island here, just has one cabin on it. But look at the size and the shape of this thing. This is a roche montée. Here's my abraded side. Isn't that beautiful? Coming up to the top, there is the plucked quarry side right there. And there's the rubble pile at the base of the plucked side. This tiny little island just shows that. I know ice was moving through here from right to left. Remember that first shot that we looked at? This is what we call a pressure form out here. If we look at it again, you'll notice everything's nicely polished and striated. And look at how it kind of just curves around. And that's because as the ice was coming up, it was pushing a lot of pressure on that part of the island. The ice really melted, and it just scoured out this curve. And they call those pressure forms. And you can see the striations here, just beautiful as that ice moved across the granite. Easily seen. Here's something we haven't talked about. It's kind of cool. These are called friction cracks. And you can see them here, these kind of little bow-shaped things. You can see the scale here to give you a sense of how big they are. And they're all over the place. And again, we've got a direction indicator. If they point, okay, ice is moving from right to left. If the smile points upstream, we call them lunate fractures. If the smile is pointing downstream, we call them crescentic gouges. Terminology just to confuse you, right? And if they point upstream, but there's no rock material removed, it's just a crack, then we call it a crescentic fracture, not a crescentic gouge, which points the other way. I know. The guy that invented this ought to be taken off the shelf. But look what I can do with these guys. Sometimes we kind of just call them chatter marks, because what they're formed from is debris that's in the base of the glacier. And this chunk of debris is just kind of coming along and it whacks into the bedrock. And it gets picked up by the glacier, carried along, whacked into the bedrock again. So it's just chattering along, just bouncing along. And every time that it comes down, it just smashes into the bedrock, fracturing the bedrock, leaving these marks. So they're just chattering. And you can just see here where we've got different parts. Here we can see fracture with no rock removed. Here we can see where the rock chip has been taken out. So we kind of look at them in a couple of different perspectives. Okay, here's what they tell me. They're always curved. So just connect the ends. Put a straight line. So you kind of think of bow and arrow, okay? So you're stringing the bow. And you can see that I've done that on a couple of them here. Notice the smile points in different directions. That's the first step. Then just draw a line like you were stringing the arrow on the bow. Okay? And now you want to figure out which way was the ice going. You know the ice was moving along this line one way or the other. But here's the trick. Notice in this particular smile here, the rock chip that was taken out is real gentle and kind of shallow slope here, leaving a real steep edge over here. Steep edge, gentle chip. Okay? That means this ice was moving across from the bottom to the top. If you look at this one over here, though, it's kind of just the opposite. It doesn't show quite, the perspective's a little funky, but basically this is the chip here, and this is the steep edge. So no matter which way the smile points, whether the smile's pointing upstream or downstream, notice the sharp edge is always the upstream side.